In this video we're going to have a look at the 2017 question 1b for linear acceleration. So in the question we have a bag and chute which is two sections P, Q and then QR as shown in the diagram. PQ is smooth, and remember when you see smooth it means that there's no friction. So that's a really important part of information or bit of information there. It's a quarter circle of radius r. QR has a length d and is rough, so that means that there is friction. It's horizontal. The coefficient of friction between the bag and the section QR is mu. A bag of mass m is released from rest at P and comes to rest again at R. So obviously the bag is going to be released from here, it's going to speed up, there's no friction here, and then between this point and this point Q and D it's going to slow down gradually until it comes to rest at R, because there is friction with a coefficient of friction mu between Q and R. So find the speed of the bag at Q in terms of R. Right, well, even though this is curved, because there's no friction, it means that there's nothing taking away energy from this bag as it falls. So really, because there's no friction, its speed is going to gather much in the same way as if you had a bag and you just dropped it a distance r, and its gravitational potential energy was converted into kinetic energy. So that's what's going to happen here. It has a certain amount of gravitational potential energy, and all that gravitational potential energy is going to convert into kinetic energy. Now, when we do this kind of situation here, we assume no energy is lost. We assume that air resistance is negligible. And really, it is fairly negligible for most things. Because this has no friction, we can actually say that it's more or less the same as this. There's nothing slowing this down except for air resistance, which we consider to be negligible. So if we want to find its speed here, we can say that its GP at the top is equal to its kinetic energy at the bottom. All of its gravitational potential energy is converted into kinetic energy. So that means its mass times gravity times h becomes a half mv squared. M's cancel, so v will be square root of 2 times g times h. In this case now we can write as r, because the height is dropped from as r. So that's your answer to part 1. That's an expression for the speed of the bag at q in terms of r, and it's important we put in the r, we don't leave it as h. And I think that was worth 10 marks in the mark scheme. Now part 2 is a little bit trickier. So part 2 says find d being the distance from here to here, in terms of mu and r. Well, what's happening between q and r? So between q and r, it's decelerating. And if it's decelerating, it means we can use two equations. What equations do we always use when there's acceleration or deceleration? We use u-vast equations, or we use F equals ma. So these are definitely the equations that we're going to be using. Now, if it's decelerating, it means that there's a resultant force which is in the negative direction, in the backwards direction of it. That force is due to the friction. And we know that friction is equal to mu times r, where r is the reaction force, not the point r, obviously. So that'd be mu times mg. So we've one equation there. We can say, well, mu times mg equals ma. So there you've one equation, because Fr equals ma. So that's one equation. Another equation we can use that involves distance would be one of the u-vast equations, which involves distance, which would be v squared equals u squared plus 2as. Now with these questions, it's just a matter of playing around with the numbers and the figures until you can get what they've asked you for. There's no kind of straight way, this is what you do. But what I like to do is I like to write down all the possible equations I can use and work from there. Well, what do we know? We know that it's at rest at r. So we can say v is going to be 0. We know that its initial speed is what we figured out in part 1, which is the square root of 2gr, and that's all squared, plus 2 times a times s. So that gives us 0 equals, well, the square root of 2gr all squared is 2gr, plus 2as. So that gives us 2as equals minus 2gr. Now we're looking for d. in terms of mu and r. So d, sorry, would be my s here, wouldn't it? That'd be d there. So I should have replaced that with d, 2 times a. So now we've got two equations here, and we're looking for d. So now we just play around with these equations 1 and 2 to try and get d in terms of mu and r. Well, we can get an expression for a here. A would be minus 2gr over 2d. They'd cancel, and we'd get a equals minus gr over d. So now we have an expression for a, and we could put that into our equation too. M's will cancel. We know a equals mu times g, so therefore minus g r over d equals mu times g. G's will cancel, won't they? And d will be equal to r over mu. Is that correct? Yep, that's correct. So there's our expression for d. Now one thing I didn't include there was the minus, and that's because the acceleration and the force are in the same direction here. So even though I had a negative value here, really I could have put a negative value for f here, because the acceleration is in that direction and the force is in that direction. So that's why I kind of discounted the minus there. And that's part 2. Now, as I said, that's just a matter of playing around with it. You might do it the same way as me. You might play around with it a different way, but that's one way of getting the solutions. And they can be tricky because if you don't see the answer straight away, it means you can kind of get caught in a bit of a hole and waste time trying to figure it out. If that happens, move on, go to the next question and come back to it. So the speed of the bag when it's halfway between Q and R, so when it's here, is 7 meters per second. Find the value of R. So we're going to be using our UVAST equations here. Our initial speed again would be square root 2gr. And this time our final speed is going to be, what was it, 7, was it? 7. We know an expression for acceleration is minus gr over d. And our distance s is going to be our previous d divided by 2. So we have v squared equals u squared plus 2as. 7 squared equals square root 2gr all squared plus 2 times minus g r over d all over d over 2. And using d over 2 here is important because that allows the d's to cancel. But again, that might jump out at you right at the start. It's a matter of playing around with these, and it's just practice. 49 equals 2gr plus 2's cancel, d's cancel, so minus gr. So gr equals 49, which means r equals 49 over g, so r equals 5 meters. And that's your answer.